Hi, DevOps Summit Canada. I hope everyone's doing well today. This is Micki Boland with Checkpoint. I am an architect here, focused on cybersecurity, work with a lot of developers, application teams, security teams, cloud architects, and so forth. So I'm really glad to be with you guys. For developer, um, perspectives this year, I thought it's super important to talk about application security. I've been doing a lot of stuff with OWASP, SoCal, and other things, and I want you guys to understand that we understand that you're under a lot of stress in coding and actually, enriching applications that you're delivering for your business and to your customers. And we want to make your lives easier. So, one of the biggest areas of focus for me in 2024 is going to be API security. It's kind of a super important thing, and I'll tell you why. But I want to talk to you guys a little bit about application security in a term of called AppSec or Open AppSec. And this is a thing that Checkpoint's developed. We have an open source community, and I'll show you that. You can go and play with this and see how it works. But it's basically a way to use machine learning and neural networks to protect your web services and your APIs. Using a really good company that knows cybersecurity, knows threat intelligence, and uses AI for a lot of threat intelligence. It's basically a way for you guys to plumb security in and not create additional headaches for yourselves. So let's get after it. I'm going to talk about AppSec, Warrior Web and APIs, why it matters, a little bit how it works, and the architecture under the hood. And then we're going to get right into the playground. So I will take you to openappsec.io. That is our open source community. It's free. You can go play with it. Even if you want to use it now, you can. The open source community version uses a CrowdSec, so you can use CrowdSec bouncers and kind of cool stuff there. If there's time, I'll talk about it. If you want advanced threat prevention through our threat cloud, it is a pay for service, but I'm going to show you the open source, and we're going to run through a quick lab deploying AppSec or Open AppSec on a Kong API gateway, which should be pretty fun. All right, best practices, you guys know for web and APIs, it's super important. I don't really think I have to tell you guys this, so I'll tell you that we're seeing increased attacks on APIs. Again, this is an area of focus for me. It's going to be pen testing APIs, and it's also going to be doing security, advanced security, and also getting the word out. Because right now, Akamai says that 81% of all internet traffic is actually from APIs. Gartner in 2022 was already saying that APIs were the most prominent attack vector. So the most frequent attack vector that they were seeing. And I think Checkpoint would totally stand by that as well. Let me turn off my camera now here for a few. Uh, we also know that APIs are usually kind of bypassed for security testing, and that is probably one of the reasons why they are such a frequent attack vector. Also, the fact that a lot of customers have APIs that are exposed to the public and they don't realize it. They also don't always look at the logic flow of these, and this is important. So, Coinbase, we had T-Mobile, Venmo, Peloton was one, LinkedIn, Experian, Instagram, and Bumble. These were all attacks that were attributable back to APIs. And I'm not picking on these companies. I think it's so important. And it's kind of like there, but for the grace of God, we just may have not been attacked yet, but our APIs are definitely vulnerable, and you want to know about this. So today, of course, you care about the OWASP top 10 web and API securities, the risks and the security protections. You also have to worry about governance, risk, and compliance, testing, cybersecurity teams, your security operations. And you also have to be able to provide both web and API security, data security, and business logic. And that means you have to document these things. Also recommend that you use open API specification and document therein. It shouldn't be optional. The logic, the business logic, and the flow logic are two areas that are frequently left out there. Also, a lot of times APIs are over provisioned, and they also have direct access or the potential for direct access to sensitive data. So a couple more best practices. Without documenting business logic, these things should not be in production. And you have to test. You have to build security in, and you have to test. That means the stuff you're already doing, SCA, SaaS, DAS, but you need container security, you need web application firewall, that it needs to be like a machine learning type firewall. You can't just try to like set and forget these things and worry about signatures, because you won't have time to, and your security teams won't have time to deal with the WAFs, especially different cloud native WAFs. You want to actually use machine learning and AI to deliver updates for those and protections for those. API security has to be, and usually these two things don't always go together. And then you need rate limiting. You also want to reduce false positives, because the last thing you guys want as developers or application owners or dev team leaders is that you have security teams coming to you and saying, hey, the application you guys just released or the new features, there are software issues, there are security holes or vulnerabilities or bugs. And then you guys are told to fix these things, and it turns out to be a false positive or something that you have to have on board. So you want to use also AI-based threat intelligence. It has to be more than signatures. It has to be behavioral, heuristic. It has to be learning how the application or the API is being engaged, and see how things are actually going, to know that that's a real threat to the web or API. And then we have to protect all this stuff in real time and deliver security back to the business in terms of the security operations teams and all the other people that want to know governance, risk, and compliance. And definitely from a risk perspective, that you guys as developers are doing all you can to develop extremely good and efficient and delightful applications, and you're not trading off security. I will just show you guys this. The coolest thing about this is you can deploy this in an automated fashion from your pipeline. You can actually run a security child pipeline that actually plumbs the agent in. It will deploy with your application wherever it is deployed on. And also, if you want, it can be all CLI or IDE or from pipeline build. It can also then phone home and actually establish communications with this management dashboard. So then you can give it to your security teams to go and actually look, and you guys can look at stuff together. On the API side, I will tell you guys that I have some customers using this that actually one, inventorying and identifying exposed APIs, and then they're also actually looking at how well they're developing their APIs. So I think that's something that needs to be said. This is not a sales feature, but this is all machine learning and neural networks. So the idea is that you don't spend a lot of time, and your security teams don't try to spend a lot of time training this. He trains himself. I want to make sure that you guys understand that also preventing bots and also protecting against like the growing level of API and web CVEs is important. Protecting files that are uploaded to your web apps and your API servers is crucial. That's included, and also rate limiting. We can also ensure that we can inspect HTTPS and traffic. And let's see what else do I want to tell you. We work with GraphQL API, REST API. Everything can actually be hosted in a dashboard you can deploy using infrastructure as code, as we talked about. And we have millions upon millions of the machine learning. The first part is the supervised learning. We have millions of offline type train information about web and API attacks. And then the second part of the agent is that it actually does machine learning and neural networks with the application in runtime. Interestingly enough, our application security, the AppSec key prevented these attacks before they were actually even known. So there were CVEs, there were behavioral things that were going on, and we blocked these attacks before we knew exactly what was going on. It's kind of one of the things that we're pretty happy to share. So the first phase is basically decoding the payload. So this is actually looking at this engine is looking at the fields of the HTTP or HTTPS request, including URLs, headers, JSON and XML extraction, base64 and other decodings. And then basically we compare that to what we already know and we score it. So we find indicators and then we score them. In the example of log4shell, there were some exploit attempts that were done with base64 and trying to escape encoding, and that was actually one of the indicators. In the second phase, we actually take this and feed it into now a neural networks engine that is looking for attack indicators and patterns. So we're seeing how the actual application in runtime, the web or API, is actually behaving in runtime. So we take all the information we did from the first phase, and then we see what's really going on in the second phase with the application in runtime. For example, in log4shell, we saw several indicators. It wasn't just one thing. It wasn't the base64 escape. It was also command injection, remote code execution. And we saw other payloads that there were on their own merit, they would have been like high risk score, but actually with all of these things combined together, we identified that it was a very high risk and it was not a false positive. So then we move to the third phase, which is basically this complete evaluation engine. So it's a final determination whether the payload is malicious, and that's including all of the previous crunchings here. And then we give it a confidence score. So the idea is that you're not getting false positives. There's part of our engine that's actually specifically meant to remove false positives. And some of these factors include like reputation engine, application awareness, user input. So we're looking for like special types of input that can cause false detection. And we actually strip that out and say that's not behavior that's compromising that comprises rather a real attack. And that's part of our false detector factor. And that's how it works. If we see that it's a high risk, we actually will block on this attack. Again, the idea is that we're delivering very low number of false positives. This is extremely fast, not impacting your performance at all, and that we're looking for both known and unknown zero-day attacks. This is a runtime protection, but also is going to show you how where your code is weak or your APIs are weak. Part of the engine that comes with this is a bot detection. So our bot detection basically is to identify, automated processes. So these are bots that are running through automation. We inject a script into the web page. We collect data about the input patterns and keystrokes and mouse moves and finger touches. And then if it's a bot, we identify them and we make a decision if the input is a human or an automated script, a bot, and we block this activity. This is a big thing for customers. The other thing is for API, we use schema validation. So we use open API specification we actually can identify if your schema is proper. And I think this is where we would tell our engine to use Open API. Like we'll upload that into the app sec, and then we validate API requests against these schemas. So anything that's not that doesn't match the schema is blocked automatically. This is working for Open API schemas v3 and above. We also have a negative model that uses WAF and automatically detects and blocks malicious payloads in the API. If you have any questions about the schema validation, let me know. This is very powerful. All right, architecture, moving along. So we have a nano agent, or you can use a full virtual machine. This is for public and private cloud. You can run it. Again, the agent can run on a container. It can run as a virtual machine. We can put it as an agent on Nginx, so it can be a reverse proxy web server. He can be deployed as a sidecar with Kubernetes ingress controller. And we can deploy on Kong API gateway, and we can manage with our portal, which I'll show you. So this is super lightweight, small software component that's deployed on existing web server, reverse proxy, ingress controller, serving as a reverse proxy with or without, or I'm sorry, without changing the architecture. This is totally frictionless, easy to deploy, doesn't change anything, and gives you everything you need. You can deploy with Helm charts. For Kubernetes, he's ready to go. Nginx, it's already integrated in the ingress controller is already integrated with the AppSec agent. We can deploy using Helm chart, Kubernetes annotations, Terraform, or GraphQL API. And it's just a small agent attachment. You'll see HTTPS transaction handlers, orchestrators, and a watchdog with the attachment. The architecture, so there's a couple of places you can go see openappsec.io. I'll show you in a minute. You can do a local declarative configuration, so it's local. You can use cloud native configuration as code, config files, YAML, CRDs, annotations. You can do local management only, like just put the agent on there. It gets all the threat intelligence updates. It already knows about the first supervised learning, gets his updates. If it's open source, you can use CrowdSec and Crowd Bouncers. We also have integration for Prometheus and Grafana. You can also, but wait, there's more. You can also use a web-based config. So that portal I'm going to show you basically allows you to host that up for your security teams, and also lets you see real threats against your applications in runtime, which will make your coding better. It's easy to go, easy to use. There's no training for you. There's all the events are there for you. This is, again, correlated with our threat intelligence. And again, using you can use GraphQL API. All right, let's look at the actual how this thing works. So this is the Open AppSec IO playground. We'll show you right now. And if you go to this site, you'll have to create an account to actually run in the playground. You won't get spammed. You won't get we don't share your information, so it's completely free and available to you. So you go here and then you just pick your poison. So the kind of the approach, how do you want to deploy? Do you want to deploy with Nginx? Do you want to deploy with Kong or Kubernetes ingress? And this, I just clicked the playground for Kong, and I'm going to run through this lab with you guys. So there's my there's where I want to go. I'm going to deploy with the Kong API gateway. I will get, I'm going to run a little SQL attack. It's going to be just kind of a joke for you guys, but it is a little SQL attack that I can show. We're going to deploy this now to show that you can try to run an attack against employee details API. So we're going to try to exploit it by performing the the attack, the first thing we also are going to do is grab a token that we can then use to exploit. So we are trying to get an employee list for John Smith. And now we're going to try to run the request with, and we get it, right? We do get it. That worked out great. Now we're going to try to run a SQL injection and get using that token. And we're going to try to find out if we can get additional information. So are we getting protected employees information? And we will see here in a second. There's the first run. Now we're running with SQL injection. And you see that we're getting other employees information. We were able to break the API and get confidential information. So that kind of is a problem that we need to fix. So the next thing we're going to do is actually deploy Kong as the API gateway. So let's go ahead and look at that. We're going to download and deploy Kong. We're going to go ahead and use Kong or configure Kong as the declarative, so local database or local configuration without the database. And then we're going to forward the traffic to the application. We'll restart Kong. Hopefully this isn't going too fast for you guys. And then we're going to try to access the API through Kong. So we're going to go ahead and navigate there. And you can see that we're able to access the application. So now let's through our Kong API gateway. So now we're going to deploy Open AppSec or AppSec to protect this API. The first thing we're going to do is download Open AppSec for Kong. There's an install script that's for us. Super easy. We'll run the installation script. So you're looking for a local database. Now we're going to actually download the relevant software and add Open AppSec to Kong. It's going to do an automated policy, prevention policy as soon as we download this. He will ask you if you want your email so you can have any technical questions answered, or if you need certain updates about the deployment in real life, it will do this as well. So you can actually see the orchestration, the attachment, the transaction handlers. You can see that's actually deployed. And now we're going to go ahead and you can also see what the policy is. You can actually stop and start the agent, and you can view logging from here. Obviously, this would be okay if you're getting security logs from here, but probably you want to either forward them to someone or actually use the management platform. So now we're going to validate our protection. So we're going to run the same SQL injection against the API, and you can see this time we actually stopped the attack. So let's see what the AppSec logs show. So this actually shows that we blocked the attack. It was prevented. And you can see what the indicators were and the match indicators. You can see all the scoring that takes place under the hood. So you could actually set this thing basically and let it go. Of course, you still have to explain to the business, how are you dealing with security events for your APIs. In this case, you can actually attach this now agent to a management dashboard. In this part, I'm going to just show you, we've already deployed the agent. So we just said we deployed the agent. You want to manage it from here. We're going to use the Linux embedded agent. We're going to go back and change the deployment to Kong application security. And then we're just going to do a couple of things. If you notice over here, he wants us to do first enforcement from the management portal, which we will do. And we want to say we're managing this locally from now. Instead of being on a file and on a local attachment, we're actually going to manage it from the SaaS portal now. So let's go ahead and enforce it. And then there are a couple of things we're going to do. We're going to download the tools package. which we pretty much already did with this script. And then we're going to actually connect our deployment via API key. So that's what we're doing here. Takes just a few minutes for us to communicate and attach that agent. So you can see that nano agent was attached now to the fog. So now we can actually go to that portal and start looking at things. Let's go over there. We want to go, so the next part is looking at events in and monitoring them from this open AppSec portal. It's funny, he says powering up, um, be patient, spinning internal web services. So the next thing we're going to do now is we're going to run this attack again, which we just did. And what we want to do is see that this now, this threat intelligence on this prevented attack now shows up in the portal. So we can tell all the people about what's going on. We can send the information from the command line and file structure and parse and stuff, but we can also provide a centralized logging area where you can see the attack. This is a SQL attack. Here's what happened. It was very high. It was prevented. You can see the package policy and you can see all the threat indicators. So now you actually have telemetry into a dashboard. You can run reports. You can share this with your cyber teams and everyone, your cybersecurity teams, and everyone's happy. You can also show the business that, hey, these are all the attacks that we blocked with OpenAppSec or AppSec. So if you want, if you play with the playground, it's super fun. I like the Kubernetes ingress as well. You can submit for more information. You can basically provide feedback here, and we love your feedback if you want to, run this around the block and give us some feedback. Also on the Open AppSec site, it's openappsec.io. You can see, I'll show you in a second with this next slide. We already ran through the playground. If you go here, you do have to create an account. It doesn't cost you any money. You don't have to give a credit card. You can cruise around, look at the tech docs. Most of these are open source, so you can see everything. If you want to do the playground, you have to quickly register, though, and then you can run through the playgrounds. And we'd love if you would test it and actually deploy it. Go out there and check about the CrowdSec. So if you want to try the open source version, it's an open source community. You're welcome to do it. We would love if you would. It does the supervised learning. You get that part, and also you get bouncer. You can bounce stuff using CrowdSec. There's an integration and notes. You can see it's just there's a couple little pieces to do. And but if you want the advanced threat intelligence and the advanced neural networks, then that's a premium version, and we are happy to help you with that. So with that, I would love if you guys also, if you would connect with me on LinkedIn. It's Michelle with the 1L. My mom was French. So connect with me on LinkedIn. Let me know your feedbacks. And with that, I'd like to say big thank you. Take any questions from you guys. Always here for you. And last year, I talked a lot about why hackers are targeting developers and what to do about it. If that's something that you guys want to review, let me know. I had to do some new stuff for this year, but that was a big focus last year. But API security, you guys, API security. I'd love to hear your feedbacks and insights. So please don't hesitate to reach out. And I just want to end this and say thank you very much and wish you a very great conference. Thank you.